I want to talk about SigmaPlot today, and I want to give you an overview about what you can do with SigmaPlot, from data visualization to running some kind of statistics. All is possible with SigmaPlot. And yeah, there are some things I want to show you. As Dorian already mentioned, my name is Sebastian Wassenberg. I'm a statistical consultant, a data scientist since 2012. So I work with data over 10 years now, analyze them, sometimes fight with them, and of course, visualize and report the results. And I usually work with medical and psychological data. So that's why I will use some sample files from these fields. If you're more familiar with other fields, you might have more specific tests. I think some of them you will also find in SigmaPlot. But maybe I might not be the perfect person to answer your questions regarding those highly specific tests. But of course, feel free to ask questions and we will try to answer them.
And yeah, Sebastian, I just closed the poll, and for your knowledge, half of the attendees have not used the SigmaPlot before, and half of them are using different versions. So then you know.
Okay, so perfect. So I think it's great to give a broader introduction to SigmaPlot. Yeah. SigmaPlot. Second here. A very short description what you can do with SigmaPlot. It's now version 15.1, and you can use SigmaPlot to explore and visualize your data with graphs. Why explore? Because usually you want to know more, you want to get more insight using data. For example, what products are best or sold best, or is there an association between two variables or something like this, or a difference between 2 or 3 or 5 or many treatment groups regarding a specific outcome. That might be your question. So you want to run some kind of analysis, but first, before you run any kind of statistical analysis, I encourage you to explore your data, to get to know your data. And the best way to get to know your data is by computing some numbers, some descriptive statistics, for example. But numbers are only one way to do it. Sometimes a graph is much more helpful to visualize your results or your data, to get a feeling what's going on in your data. And if you have a feeling what's going on in your data, you might want to prove your feeling. You don't want to report in a paper, oh, I had a gut feeling for this and that. Of course, you need numbers. You should be objective, because sometimes you have a feeling about something, but the real life data tells you a different story. So you want to run some kind of statistical analysis with your data, and you can do so as well with SigmaPlot. It's called SigmaPlot, of course, for a reason, because it was once created or developed to create publication-ready graphs, and a lot of different graphs, of course. But you can also run statistical analysis using SigmaPlot, because in some plots you use the results of some statistical tests and then visualize the results you got in a graph. And you can do so as well with SigmaPlot. You can analyze your data and visualize the test results. Of course, not every statistical test will get a graph, because the more advanced your statistical method is, the more likely it is that you need to report it as a table, because there's no option anymore to report it as one graph alone. But for many statistics, there is a way to report it in a more, or in a nicer, more compact way with a graph. And the huge benefit of SigmaPlot is that you get publication-ready graphs. So when you want to publish your manuscript in some journal, the specific journal might have very specific requirements regarding your graphs, that they need to be in some specific file format, or that you need some specific kind of resolution. And you can all address this when you export your graphs with SigmaPlot, so you get very easy publication-ready graphs that you don't get so easy with other programs you could use. There are also some favorites of mine while I used SigmaPlot, and I think I will show you it right away here in SigmaPlot. First of all, when you start SigmaPlot, you get this quick start dialog, or maybe you don't realize that you got it because you see something like this. Open a notebook, okay, some info, maybe some files you used. If you want to familiarize yourself with SigmaPlot, maybe you have a test version or something, and you want to know what's possible, use the other tab, not open notebook tab. Click on the Create Graph tab, and there you see what's possible with SigmaPlot. There's even more to SigmaPlot than you can see here, but it's quite a variety of different graphs you can create, as you can see. And when you have such a variety of graphs, there is no way to have just one way to enter your data. So you don't start by having your data and then think about, what graph can I create with this kind of data? You should think about it before entering your data. That would be very, very good, because some kind of graphs need a specific kind of data entry. Some kind of graphs can have a flexible data entry, so you can use or enter your data in many different ways to get to the same plot. But the more advanced your plot is, the less likely it is that there are many ways to enter your data. There's usually just one. And that's why you need to know how to enter your data. And depending on the software program you want to use, there might be different ways. Of course, SigmaPlot has also specific ways. They don't deviate, usually don't deviate from the general data entry you see in all statistical programs. But for some graphs, they might be different. And here, when you can see, where you see all the different graphs you can create, you can click on just one, for example, scatter plot. And then you can see here basic regression lines and so on. And maybe you want to have something with error bars. I just use this one. Then you get a little graph preview. Of course, it's very little here on my screen. If you use it on a larger screen, of course, it will be larger. So it's depending on my laptop screen here, that it's small. But you get a glimpse of the an idea of the graph you can create when you choose this option. And it's also very helpful, you get a worksheet preview. So you get a preview about how you should enter your data to create a graph like this. And as you can see here below, you have also very many options sometimes. Okay, do I enter the raw data? Do I enter some summary statistics, or do I want to compute the values I want to show here in this graph using my data entries? For example, I have columns and I want to report the column means in my plot, but I have the raw data in columns, not the means itself. themselves. You can choose whatever options you like, or you can familiarize yourself maybe first with the options you have here, so you can see what is possible. And often you have different ways to enter your data. That's regarding the worksheet here. And you find these different options here. And again, you see next to this drop-down menu, you also get a little preview how to structure your data. So what columns should you have, depending on the options you choose here. And that's something I think is very helpful, because when you have such a huge variety of graphs, it's just not possible anymore that you have only one way to enter your data and to create everything with it. It's just not possible. So this might be one way to get familiar with SigmaPlot. Okay, what kind of graph can I create, or what kind of graph do you want to create? Choose the specific graph, maybe a radar plot when you want to plot some kind of profile. Then a radar plot might be a nice solution, a nice way to visualize it, or some specific kind of graph I've never saw in my field, because in medicine or psychology you never work. I never saw them before, these ternary scatter plots. I was told you can use it in chemistry when you want to visualize some the ratio between some substance concentrations or something. You can create this very specific plot, for me, very specific plot in SigmaPlot as well, or usual ones like pie charts, or more advanced ones like forest plots when you want to run a meta-analysis, and you can actually compute a meta-analysis with SigmaPlot as well. You don't have to use anything else. But of course, you can use anything else to get numbers. But if you want to create the graph for it, you might want to use a SigmaPlot, and you can use it here as well. So also a very different kind or way how to enter data, because a forest plot for meta-analysis is a very specific plot. Okay, so that's one way to get you started. And there's also another way. You see here very different tabs. We have the home tab, the worksheet tab, where you find anything, for example, how to import data into SigmaPlot. And it's also quite nice that you can import very different kinds of file formats. Maybe your favorite one will be Excel, because you all usually know Excel. But maybe you have also data in plain text, or something like comma-separated files, also plain text, but a specific format. Or you used some other kind of statistical program, SAS, for example, or you have IBM SPSS statistics files or something like this. You can also use them, these data files, and import them in SigmaPlot and create your graphs there. That's what you find under worksheet. You can also format the way you see here. It's also under worksheet. Then we have the create graph tab. I will talk about it in a few seconds. The graph page as well, also in a few seconds. Analyze, there you find the statistical analysis you can run with SigmaPlot. And you have the report, because when you run an analysis, you get a report for this analysis. You can edit this one as well. And something when you wonder, okay, I heard I can create something, for example, like heat maps with SigmaPlot. I can't find them here. Maybe it was just a hoax. I can't create heat maps with SigmaPlot. I can't find them under analysis. Yeah, that's okay, because a heat map is not a kind of statistical method. It's a specific way to report values. So, such specific graphs or analysis you will find under tools. There, for example, you find heat map or advanced statistical methods like ROC curves or ROC analysis, or a very specific kind for medical analysis when you want to compare two devices with each other regarding their agreement. So maybe you want to compare one device and a new device, and you want that both get the same measurement, then you might want to run a blunt-Altman comparison to tell, okay, is the agreement very good between them or not? Or maybe in a specific area it's good, and another one it's not so good. That would be a blunt-Altman comparison, very specific. And that's why you find those very specific tools under the section tools. And I wanted to show you the help tab for now, because here you find user guides as well. These are PDF files that you can read, of course, but sometimes nowadays we all expect, the program needs to talk to me. I don't want to read something about it. And if I have to read something, it's not a good program. If you have a program with with a lot of options, yeah, you might get soon overwhelmed by all the options you have. So you might want to have some structure, and user guides give you this structure to get to know your program and to get the best out of it. And in SigmaPlot, we also have these sample files. For example, if you want to know, okay, what's possible, you have sample files for graphs. And when you click on it, it will open a notebook called samples, and it's created to show you what is possible. For example, that you can create graph like this. It's not meant to be to tell you, oh, this is a beautiful graph and that's the way to show it. No. And what is beautiful and what's not, it might be very subjective. Of course, but these examples are there to show you what is possible, so that you can mark, for example, single points here, or that you can create this kind of regression lines here, and that you can see, okay, maybe this is a graph for you that might be interesting for your data as well. Then you have also the worksheet for this plot. So you can have a look at the worksheet that was used to create this according graph. So you get a feeling about how to enter your data. And that's something I think it's very, very helpful. Other statistical programs have this kind of help and sample files as well, but in SigmaPlot they are much more better structured from my point of view. So maybe you want to start here. For example, if you want to know, okay, heat map, that's something new in this version, then you might want to see examples for this. And I think examples for this are under macro data. So maybe you want to use, or you want to open all sample files to see what is possible. And for example, as you can see here, I can create a heat map with SigmaPlot, and you might wonder, how can I create it? And maybe a first thing would be to have a look at the data. How is this data structured and entered here to create a plot like this? And of course, there's also a guide for this, or some kind of webinar specific for creating heat maps, what you can do with it. So these are a few things to get you started. on your own to explore SigmaPlot. Use the quick start guide here, or use the help tab and use the sample files to get your way around SigmaPlot. You already saw a few favorites of mine, because sometimes you might not be so sure what kind of graph might be useful in your situation, or what kind of analysis might be useful. And here you have guides or wizards in SigmaPlot. A wizard, for example, for creating graph. So you can first choose, okay, what kind of plot do you want? A scatter plot where you have single points, or a line plot, or a polar plot, or something like this. And if you choose them, you can go further and further. So it might be a better way to go this way to find the specific plot you want to create. You find this same wizards, or here they're called advisors, for statistical analysis. Maybe statistics is a new field to you, and it's sometimes overwhelming, and it's with everything. Maybe you had one workshop about statistics, but it's like learning a new language. If you don't speak it, you will forget it. And it's the same with statistics. When you have one workshop and you don't apply your knowledge that you gained in this workshop, you will lose it, you will forget it. So maybe you might recall some kind of test names or so, but don't recall when to use which. Here in SigmaPlot, you have an advisor to help you find the correct test. For example, here, the first question, what do you want? Do you want to describe your data? Do you want to compare groups, predict a trend? When you say, okay, I want to compare groups, you can choose it. Click on next, then you're asked, okay, how are your data measured? Was it numeric variable values, something in meters, degrees, or some kind of other unit? Do you have values that are just ranks, or is a ranking something from small to higher also? Or do you have proportions, or do you have something very specific, survival times and survival analysis? Then you might need another test. If it was numeric values, you can choose on next, answer this question. Okay, how many treatments per subject? More than one? Maybe not. Then, okay, how many groups do you want to compare? Okay, I want to compare 3 or more groups. And then you get your suggestion. And here the program suggests to run a one-way ANOVA, a one-way analysis of variance, which would be the correct test in this scenario. And if you have the data to run this test, you can click just on run and select the specifics here. Okay. This is the guide, and you have often a flexible data input for your graph and for your statistical analysis. And to show you what I mean, I will use the sample data for statistics, because here, when it comes to an unpaired t-test, that's a test you can use to compare 2 different groups regarding a numeric outcome or a numerical outcome. Then you see here in this example that you can enter the data in 3 different ways. And that's something very nice. The usual data entry would be something like this. This format is called the indexed format in SigmaPlot. Indexed meaning you have one column telling you to which group the specific person, each person belongs. So one row would be one person, one case. And then you have another column with the outcome response here in this case that you want to compare between these groups defined by this column. That's the usual data entry you will find in other statistical programs, or might be familiar with in other statistical programs as well. You can also choose to enter your data in a column-wise fashion. So you have one column per group. And again, one cell here in each column would be one case. And so you can see when you have more cases here, you have a longer column than here. It's also a way to enter your data. As you can see in both cases, you have the raw data, meaning you have the data for each and every person. But if you have a t-test, you don't need the raw data. You can also enter summary statistics. A t-test is used to compare means, the means between two groups. So you might just want to enter those means. And you can do so in SigmaPlot as well. Just enter the means, the standard deviation per group, and the sample size for each group. And now it's different. Now one row is one group and not one subject, one case or so. It's one group. So if you have many groups, you would have many, not only two rows, you would have many rows, each with these group-specific mean and the group-specific standard deviation. And maybe you wonder, why should I ever need to use this? If you, for example, want to rerun an analysis based on data that you found in a published paper, maybe the authors of this paper missed something or didn't report a specific comparison that you're interested in, then you can just run it for yourself. Enter the data that is reported in this paper and in this way, and you're good to go to run your statistical tests. And yeah, I will just run it, as you can see how it is done. I want to choose a t-test. I can go to the Analyze tab for this and go to the drop-down menu to select here the t-test. Or there's another way. You see this button called Tests here. Here, all the methods you have at hand in SigmaPlot are grouped in what they do. For example, compare two groups, and then you see here t-test, or you want to compare many groups. There are the ANOVAs, or you want to run some kind of regression. Also, a large variety of different regression analysis, or you want to run some kind of survival analysis. You find here the usual tests for this. I want to compare two groups. I choose a t-test. And here again, you see a little preview because it's now selected. Under data format raw is selected. So the program would expect a data entry like this. Or you have indexed, then again, it will give you a description of what it expects. And you can always look, okay, does this description match my data entry? Or if you have summary statistics, you can also choose this one, mean size, standard deviation, or mean size and standard error. Either standard deviation or standard error, you need to run the t-test. Without it, you can't run the t-test. It's not based only on the means. You also need the standard deviation or the standard error that you can compute based on the standard deviation. I choose the index format and click on next. And now I'm asked to select the column with the groups. It's gender in my case. and the column containing the data, and that's column 7 here in my case, the response. I just click on finish, and here's my report, the report for the specific kind of test. Many statistical tests are based on some kind of assumptions. We also have this assumption checked in SigmaPlot, for example, normality tests, or the assumption for equal variances in a t-test for independent groups. I don't want to focus on them today. I just want to mention that they're integrated into SigmaPlot, and that you also get a warning if, for example, the normality test fails. Then you will get the suggestion to run a non-parametric test. What is, in most cases, a useful idea or a good idea? Not at all, but it depends on you. You need to know your data to know, oh, should I really change the statistical test, or maybe you don't need it to change it. That's not something a computer can detect for sure. So you always need to know your data. But it will give you suggestions based on the numbers, because some things you can tell by numbers, but not everything you can tell by one number. So always know what you're doing. You get the results, and you get a nice narrative result as well, because in statistics you always get numbers like here t-values and degrees of freedoms and confidence intervals and p-values, and you might think, oh, what does it all mean? Here, a very nice, very short summary of the results that you can tell with the results we have here. That the difference in mean values of the two groups is greater than would be expected by chance. And if this is the case, then you have a significant result. And that's why here it's written, there is a statistically significant difference between the input groups. P equals 0.008. That's the p-value you got here. So it's very easy to get to this statistics. And maybe now you wonder, it's called SigmaPlot. I want to create plots with SigmaPlot. I don't want to create text files here. Yeah, of course. When you run, or did run some kind of analysis, you get the report, and maybe it's a little bit hidden, but when you right-click on the report, you often get a context menu, of course, and there is an option called result graphs, and it's sometimes a little bit hidden because here you get also suggestions for graphs you can use to report your results. For example, a bar chart with error bars, or a scatter plot with the same error bars. I just do bar chart, click on OK, and here we go. It's not meant to be a publication-ready graph in the sense that you can say, okay, I'm done. No. Creating graphs, you sometimes think there's a specific software solution for this matter. So I have one button, I click it, and bam, I'm done. No. Creating graphs is a little bit like creating a picture or painting a picture. First you have a canvas, then you have objects like these bars or scatter or something. And you might want to add lines or error bars, then you might add colors or change the scale or something. You can click on everything in SigmaPlot and change it. You can right-click and go to the graph properties. And when you go to graph properties, you get all options. Everything can be changed. And be aware that you have the selections here first. First the graph, then the axis, then the plot. and you might have different options regarding what axis you are on, or what kind of thing, I will call it for now, is displayed on the specific axis. So be aware of where you are, and then you can change, for example, the scaling, labels, ticks, and so on. You can add very easily breaks to your axis. For example, here we see, okay, there's nothing going on below 2.5. Maybe you want to add a break here and say, okay, it goes from 0 to 0.05. Yeah, and then you have this break here. It's nice. Or you want to start it at 1. So you see, maybe you think, okay, a break, we had just a starting point changed, but here you see the real break when I start from 1 to 2.5, that you can see you can very easily add this kind of symbols here. Because every plot should start at 0, and using breaks, it's something you can use, and if it helps to increase the readability of your data, of your graphs, use it. But don't use it just because the option is here. Use it wisely. Okay, but there is just one click for this, just one button away, and you can add something that's very hard to do in other programs. And it's also with entering, changing colors, or if you want to base the thing you see here in the graphs on the numbers in your table. That's very abstract. What do I mean with that? Therefore, I will use this box plot example here. That's a box plot. Also a nice plot to summarize your results, and you can use it, for example, also when you compare multiple groups, like these 4 groups regarding whatever we have on the y-axis. Here we have the median, and we have the first quartile and the third quartile. So the box itself represents the interquartile range. A measure for variation in your data. And by the height of these boxes, you can also tell, okay, where there might be significant difference, or which group might differ from each other. Of course, there are tests for this, so don't only use a graph to tell, there's a statistically significant difference. You can never tell by just looking at a graph. Some graphs, yeah, that's possible, but not all of them. Usually you need to run a test. What I want to show you here is that you can see the boxes have different width. So this box here, it's much larger, wider than this one. It's much smaller, more narrow. And that's something that is based on this column here in your worksheet. So for example, where is it? There it is. When I show you here the graph properties, you can see that under bar width, there was a column selected, a column in your worksheet. So that's something very nice if you want to address something like this in your graph, that you can use values for this. For example, here when I change it from 100 to 25, you will see that the first and the second box have the same width. So it's some aesthetics you can just change by using values in your worksheet. And you can do so also with color. something I don't want to show you any further, but you can see here in the seed map, we have colors running from yellow to purple, and in the middle we have this blue tone, and these colors are defined here also in this worksheet. So you don't have to, well, you can of course change everything in your graph here, that you select colors here in this graph, but you can also define them in your worksheet. And if you do it in your worksheet, you can just change the color here, that you say, okay, it should not be, wait, it should not be yellow. Graphic cells, that it is. It should be something else. And I think or hope. Okay, that's not connected because I think it's a very specific plot. But usually when you change it, like here we saw here, you change the way you, in the columns you selected for some kind of aesthetic, that is all instantly reflected in your graph. It's the same with numbers. When you change numbers, your graphs will also change. So data and the worksheet and the graph you created based on this worksheet, they are connected with each other. Test reports won't change when you change the data. They are not connected because you have once the data here, and yeah, they are not connected here in this case. But the plot and this kind of specific way you can use here in your worksheet for some kind of aesthetics in your graphs, they are connected. And you can also use it, for example, to create very specific graphs. That's something I also wanted to show you here, because you can create, you can, wait a second, yeah, you can run many statistical analysis with SigmaPlot. The basic test, like you saw before, right now, a t-test, correlation, chi-square test when you want to compare proportions, or when you want to tell something about the odds or risk or the chance for some event in one group compared to another, then an odds ratio would measure for you. You can run more complex methods as well, VNS of variance, linear regression, logistic regression, many kinds of different regressions. Survival analysis, you can also run something more used in medicine, but it's not restricted to the field of medicine because statistical methods see only numbers and they don't care about where these numbers came from. So you can also run survival analysis with something very else, for example, recovery rates or something like this. And there are also some kind of very specific statistical methods like the principal component analysis, something you might use in psychology or nowadays for machine learning. It's also integrated, not machine learning, but principal component analysis integrated into SigmaPlot as well. And you can create, of course, many different graphs. The classics like a bar chart, line chart, scatter plot, and polar or radar charts. Radar charts I also already mentioned. You could use, for example, here a little example for a plot for personality traits, for example, that you want to report this kind of profile for a specific person or for a specific group. You can enter here mean values, or you can enter single values, whatever you want. Or you can create scatter plots, and maybe sometimes you think, scatter plot, I can create it with Excel as well. Why bother here? Why mention it even? Yeah, most plots you see, for example, something like this here. Wait a second, I will close this window. Something you see here. This is also a scatter plot. It's a scatter plot with error bars. And that's something very specific because here you see it looks like a forest plot, and things like forest plots are also used to visualize the results of logistic regressions. And here's an example from a study, a real-life study about the risk of a COVID-19 infection, or how this risk is associated with the consumption of specific kind of beverages, and specifically alcoholic beverages. So you can see here, for example, it's not something I made up, it's real science. And you would see here, the more red wine you drink, or the people they had in the study, the ones who drank more red wine per week had lesser odds, so are less likely or had a lower risk for COVID-19 infection compared to non-drinkers of red wine. Or when you have a look at beer and cider drinkers, there it was different. The more someone drank, the higher the risk for COVID-19 infection. So you might now say, okay, finally a scientific proof to start day drinking, and specifically red wine. Don't drink beer during the day. It will increase your the risk for COVID-19 infection. Stick to red wine. This will decrease your risk for COVID-19 infection. And of course, I use this example because I like this, because you might tell, okay, now I have to drink more red wine, and finally a scientific proof for day drinking. When you have statistical results, always think about what could be another explanation for this kind of results. That you see, okay, red wine drinkers, the more you drink, the lower the risk for COVID-19 infection, and beer, the more you drink, the higher the risk. It might be just a situation where you drink, a very simple explanation, or simplified explanation, but it is one, to think about where you usually drink these kind of beverages. Beer might be a beverage for huge festivals or crowded places where you came in contact with very different people and a lot of people, and that's why the risk for COVID-19 infection is higher when you drink more beer, because you are in a different situation when you drink more beer than when you drink more red wine. Might be more a beverage for an intimate moment, or something with a special person or special persons. It might be also more than just one, but they are always the same. And so that's why you have less social contacts. And that's the important part to decrease the risk for COVID-19 infection. And if you have more and more and more social contacts with very different people, the risk will increase. And that's an explanation for this kind of pattern. So even if you run the correct statistical result, and even if you have created such a nice graph, you can do it with SigmaPlot. Here again, I want to show you how to enter your data. You need to enter the computed values right away. So you need to compute the odds ratios you see here first, enter them in the second worksheet, create columns for this, the odds ratio, confidence interval, and you can also add the labels. And here again, I choose to use a column in my worksheet to label these values here, because you would see the values 1, 2, 3, 4, 5, 6, 7, 8, and 10 usually here, but I set here that the tick labels are to be found in column 5 in my worksheet. And so they are not numbers, they are the text I entered here. And what you can also do with text is, maybe you see here that red wine drinkers and beer insider, the font is much bigger than the font here for the groups. That's something you can't change here in this plot. You can change it in your worksheet. You see this little highlight here. When you choose format text, you can do what it states. You can format the text. You can change the font size. You can make it bigger. You can change the color. I choose a red, and now I click on OK. You won't see the change here. Of course, when you hover over the cell, you see what happened, and you see it also in the graph. So that's something I find very hard to do in other programs. When you want to address specific labels, that's something very tricky in other programs, and something also you need to try maybe 1 or 2 times before to get a hang of it in SigmaPlot. But it's, when you get the hang of it, it's very easy, because when you enter text like this here, you can just right click and select format text, and then you have this special formatted text in your worksheet that is shown the way you formatted it in your graph as well. And something I think very helpful, especially when it comes to more specific graphs like this one. It's not so easy. When you have a bar chart, okay, it's very easy, but you might want to use more advanced graphs to show your results in a much more sophisticated way. And this would be a more sophisticated way to report the results for logistic regression, for example. Yeah, that's why I mentioned scatter plots, because that's just a scatter plot. You start with a scatter plot here, create graph, scatter plot. Okay, I have to choose this one. Scatter plot, and then you would choose this one, horizontal asymmetric error bars. That would be the starting point for a graph like this. And of course, you have more specialized graphs as well. I already mentioned them, vector ternary plots, or when you want to address something like sensitivity and specificity, you might be interested in receiver operating characteristics, ROC curves. You can also create it with SigmaPlot, or also mentioned Blunt-Altman plots for the agreement between 2 methods, or forest plots. The plot here is only something that looks like a forest plot. A true forest plot would have different, I hope I can show you it. Yeah, a different size for the objects here, for the effects in each study, because the values here, the size of these symbols, is the sample size of different studies. So this one here looks like just like a forest plot, but it isn't actually one. Forest plots are reserved for meta-analysis, and you can run meta-analysis. As you can see, we get the overall effect here in SigmaPlot as well. For specific outcomes, not every kind of meta-analysis out there you can run with SigmaPlot, but most of them. And also very special, now this heat map you can use when you want to report many numbers in a more easier to read fashion, meaning here I already showed you the so many files open here. I already showed you this example here, where you have multiple numbers. Here, when you hover over it, you will see this number. It's the combination of gene 1, the expression of gene 1, for example, in the intestine or in the kidney. And what you can see here very easily with the help of the heat map is the darker the color, the more active the gene is there in the specific organ or expressed there in this organ. And the brighter or more yellow the color, the less expressed it is. So you can spot very easily less expressed, much more expressed. That's the use for heat map. Okay. So a quick overview, and that's all what I wanted to show you for today.
Great, Sebastian, and thank you for the great presentation, and sorry for stopping you. I see that we have only 1 minute before our next webinar about ChemDraw. So I'm sorry we don't have time for the questions, but as I said in the introduction, we will answer them and make them available to all of the attendees and registered later on, so you will get access to them. Thank you again, Sebastian. I will switch the screen over to me.